This video is on the fifth and sixth big questions on whether there are mediating factors or outcomes that are being used as control variables. Okay, so once again, we can call on a quote from Yogi Berra. Okay, he didn't really say this, but it's something that he probably would have said if he had the chance. Where he would have said, "I would not have hit so many homers if I hadn't hit the ball so hard." Okay, so the idea here is it's actually a very similar concept to what we talked about earlier on what factors should you hold constant. And here we're just formalizing as one of the pitfalls or big questions. And the idea is that anything that is a product of the key x variable should not be used as a control variable. Okay, and there are going to be two of them. For big question 5, it's a mediating factor. Remember that a mediating factor is a variable through which the key x variable affects y. So why does the key x variable affect y? Through a mediating factor. And big question 6 has to do with an outcome itself. Perhaps an outcome is being used as a control variable. And so the lesson will be anything that is a product of the key x variable should not be a control variable. Okay, so consider this example. We're trying to estimate how does an NPS degree before length of service 10 years. Okay, so NPS, that's Naval Postgraduate School for those who are not my students who might be listening to this. And so it's basically a graduate degree for military officers. How would that then affect whether they leave the service within the next 5 years or by length of service 15? I'll call that variable leave L15. Okay, so we would be regressing that variable L15, it's 0, 1. Yeah, you could use a probability or just a simple linear probability model. So you're regressing L15 on whether a person gets an NPS degree. Maybe you could have some other factors as well. And so I'm going to argue here that there are two mechanisms for how an NPS degree would affect whether they leave. And one of those is that if you get a degree, it's going to give you greater skills. It's going to give you a good sheepskin effect, and so make you more marketable in the civilian economy. So with an NPS degree, it's going to have positive effects on your civilian economic opportunities. And with greater opportunities in the civilian world, then it's probably going to increase the chance that you leave by LOS 15 years. Okay, the other mechanism is that the degree would increase the likelihood that you get a fast promotion, and that's going to decrease the chance that you actually leave by 15 years. Okay, so those are two mechanisms there for how the NPS degree could affect whether you leave. Your beta 1 here in the model is going to capture both M1 and M2. Okay, and just for the sake of the argument, I'm going to argue that these two are independent of each other. And so the overall effect, A, the true effect, is going to be the sum of these two, M1 and M2. And so what we hope is that beta 1, what we estimate is an unbiased estimate of the true effect A. This is a true effect that we do not know what it really is. Okay, so what is going on here? The vertical axis here is just basically what the effect of an NPS degree on the probability of leaving by 15 years would be. Okay, and so M1, because it's positive, well, that's going to give us a little positive value, and then M2, it's negative, is going to be a negative value. Okay, and so this line I'm going to call A is going to give us the sum of the positive value of M1 and the negative value of M2. That's what we hope to estimate. Okay, so this was case 1 where we do not control for any mediating factors of civilian economic opportunities and fast promotion. All right, now let's do case 2 where we do control for one of the mediating factors, fast promotion. Okay, so by controlling for fast promotion, what we learned in a prior video is that when the NPS degree changes across the sample, fast promotion doesn't change because it's held constant. So that gets rid of that positive arrow that was right there, and what that means is that we can cross out M2. Okay, now this is still, it's the full effect, or the true causal effect is still A, But what's happening now is that our estimate for beta 1 is only going to capture M1, only going to capture this positive mechanism. So we've gotten rid of this negative mechanism of M2. Okay, so what we want to capture is A. We want beta 1 to capture A, which is the combination of M1 and M2, if you recall from the last slide. But what's happening now is that we're only getting M1. Beta 1 hat, again, is only capturing M1, and so our expected value for beta 1 is now going to be this right here. Okay, and so what's the direction of the bias? Well, the true effect is down here at A. The estimated effect is probably going to be somewhere up here, and so it's a positive bias. Okay, and so the general rule is that the direction of the bias is opposite to the mechanism that you control for. Okay, it was a negative mechanism in that the degree had a positive effect on fast promotion and then a negative effect on leaving by LOS 15. I'm sorry, it was a negative mechanism. We got rid of that negative mechanism, thus we have a positive bias. What we're estimating is now going to be more positive than the true causal effect of A. Okay, so when we're concerned about mediating factors, it should only be for the key x variable. So if there are mediating factors for the key x variable, it should be included from the model. If there are mediating factors of control variables, then those are okay to include. Why is that? Well, for the control variables, we don't need the estimate to truly represent the causal effect. We just need for it to capture the effects of these confounding factors. And it's okay if we're including mediating factors of those control variables. It's actually it's a good thing because we're capturing more of the variation that could be confounding factors. Okay, so generally, what to check for mediating factors? You'd want to look at the list of control variables. You'd want to think, could any of them be a product of the key x variable? Even also, does it describe some of the different types of treatments of the key x variable? Or simply just does it come after the key x variable? Okay, and really to assess how damaging that might be to a study that you're trying to scrutinize, you may just also want to think, well, how large of a potential mechanism would this be? If it's a pretty minor mechanism, then it's not going to cause any major bias. But if it's a major mechanism, then it really could cause a bias in the estimated effect. Okay, the next big question is there another outcome of the key x variable that's being used as a control variable? Okay, now here I'm going to use a real Yogi Berra quote where he once said, "Congratulations, I knew the record would stand until it was broken." Okay, so basically he's using the catalyst here is that it was broken, and he's using that as a control variable. Okay, so it's generally the same idea as mediating factors, and the problem with including an outcome as a key explanatory variable is that it soaks up so much variation in y, including some of the variation of y that is affected by the key x variable. Okay, and what you get as a result is some uncertain interpretation of, or uncertain meaning of what the estimate represents. It's a very ambiguous thing at the end. All right, let's consider this example where we're estimating how does the top marginal income tax rate affect gross state product growth. Okay, gross state product is the same as gross domestic product, but it's measured at the state level. And so I would estimate a model like this, where gross state product growth is the dependent variable. The key x variable would be the tax rate. I'd have some other potential control variables, and then state and year controls, or fixed effects. Okay, and so in model 1, I would not include any other variables, and so the coefficient on the maximum marginal income tax rate is negative and statistically significant. Okay, and this is what we would normally expect. Higher tax rate means lower economic growth. Okay, but then in model 2, I'm adding a control variable. I'm adding the control variable of employment growth. Okay, the problem is that employment growth is an outcome. Well, not surprisingly, it's a positive coefficient estimate that employment growth is probably positively related to gross state product growth, to economic growth. Okay, and when I do that, then the estimated effect of the tax rate on GSP growth is actually now going to be a little smaller. Okay, what if I add another variable, real personal income per capita growth? Well, that again, it's a very nice positive relationship. And now our estimated effect of the tax rate on gross state product growth becomes insignificant. It goes down by around half, more than half from Model 2. Okay, and so what's likely happening is that, well, now this estimate is instead of estimating how does the tax rate affect economic growth or GSP growth, it's estimating how does the tax rate affect GSP growth beyond how it affects employment growth and real personal income per capita. It's not something that we wish to care about. It really doesn't tell you, well, what's going to happen if you raise the marginal income tax? How is that going to affect economic growth? Okay, so it just gives us something very ambiguous and that probably doesn't have very much value. Okay, so what is the direction of bias? Well, I believe it's always going to be towards zero. I'm still actually kind of working on this, so I'm learning as I'm going here, but I believe it's a bias towards zero, regardless of whether the variable that you're including is positively or negatively correlated with the dependent variable. Okay, so what do you check for? Basically, you want to check, is there any explanatory variable that is a product of the key x variable, just like you would for mediating factors? Or is there just any explanatory variable that could be an outcome itself of that key x variable?